Hi guys, my name is Tainan Fidelis and here I am again to talk about a book that I have read for the second time. It was mentioned in some of the biographies made about Jeff Bezos. He read this book before building the AWS and the book is called Creation from Steve Grant. It was a book that changed my view of life, has some brilliant quotes. The guy is a genius and I listed some topics that I highlighted from the new read, and let's start with emergence. So emergence is a concept that's not easy to talk about, but I would say that it's a bottom-up behavior that's present in some complex phenomena like cities, like ants, and we have many others in the nature. And these phenomena are not controlled by a centered organism or process, but it's the other side. They emerge from the bottom up. This is the same as saying that small organisms or self-independent processes, autonomous processes that as a group form these bigger behaviors. The small parts are connected but are independent, and as a group they form these higher level entities or organisms like the anthill or like cities made of humans and every other things that make a city. The author states that intelligence is emergent. So intelligence is not some kind of thing that is controlled by a central entity, but it's formed by independent process that occurs in the lower levels, right? I like this point of view because I see the universe and all the possibilities that we have as a very large space of search. So I think we need the universe, the things that prosper in the universe have success on it to be parallel, so they can test a lot of possibilities in parallel and not in one lifespan, just doing this way but doing many ways at the same time, so they can achieve success. For me, it's like this. And this way, as parallel process, it's more nature-like because it's not like you will have every time the same output. Sometimes you may fail in one part of the organism because you depend on many smaller things, but at the same time you are more resilient to the new events, the unexpected events, the unexpected conditions that the environment, the universe will enforce to you. So this is why I believe in this concept. And the second point that's related to that are parallel processes. I talked about it as I was trying to explain emergence, but now as here in Hook Captain, we are talking about making software solutions, make technology. I think we need to think our building blocks as parallel processes in a way that if we bring these concepts to software engineering, they would have to have some features like agent-based systems or some kind of environments that have objects with capabilities of communicating with each other via object messages or call of functions or some kind of events that propagate inside that environment. But the center, the core of it is to have this environment that allow the developer to add a lot of independent and autonomous processes or agents that can interact with the environment and interact with each other. So we can accomplish this kind of emergence. And one challenge that the author talks about in the end of the book is how to format this kind of system to solve real world problems, to become real world applications. Because in theory, it's nice, it creates some kind of intelligence, it's resilient, but for solving what, right? But yes, that's a challenge that we like it to and we accept here in Hook. So emergence, parallel process that come from the bottom up, creating some high-level behaviors and phenomena. Other concept that the author brings are the building blocks of life. He used some concepts of electrical engineering to explain that, and he talks about aggregators, some gates, some diffusers, and I just wanted to note this here because yes, this kind of building block, as you read the book, you can see that they are present in our bodies, they are present in nature, and becomes clear that if we make use of them in some part of our solutions, we are turning our solutions more resilient and more adaptive. And that's another concept that he brings and he reinforced during the book, that adaptation. This is another thing that I had to study along with agent-based systems. But the thing is that adaptive systems will thrive in the future because, like I was saying regarding the universe and the environment that we have, that's changing every time, every second, every minute. We need adaptive systems that can surf, can navigate the sea in a better way. And to make a connection here, to make a link, he talks a lot regarding feedback loop, cybernetics, and positive and negative feedback, interactive feedback loop. He brings a scenario, an analogy of mountains and balls that are rolling in the mountains, and the mountains are going up and down. And intelligence for him, it's like you are the ball and you have to predict the future, use the feedback loop to your own benefit, so to reach your goals. And other agents are present and their actions also impact in the environment, so in the mountains. And intelligence is that, to understand your environment, to understand the loop that are present in our lives, the different vectors of strength that are pushing or pulling us, and the other agents that are there, and they are also have impact in this environment. So if you understand, then if you put yourself in their shoes, you can predict what they are going to do and use this kind of information to your own benefit or to your own goals as a need. And that's what intelligence is. I thought this image, this analogy, brilliant. So feedback loop, cybernetic, and interactive feedback loop are other concepts that he talk about in the book. Last 3 points. The environment features impact on the higher order components or objects that you create inside that system. So the idea is, for example, the author claims that intelligence can exist only in 2 dimensions or 3 dimensions space. So it's like, for him, it's like you need 2 or 3 dimensions to have intelligence, because if you have components or agents or organisms that have only 1 dimension, some kind of problems are much harder for them to solve, for these less capability. I don't know if I can call this name, but it's like if your environment don't allow you to move forward, make it harder for you to move forward, then you won't have this kind of high order behaviors and elements and entities and organisms phenomenon because of the environment. So it made sense for me, because I believe that, for example, in our case here in Hook Captain, we are using some kind of simulations to represent what's happening inside the system. And I really believe that without it, it's very hard for us humans to keep track of what's going with AIs and generation tools that are coming in the future. Because for them, it's like zeros and ones. They can understand binary and they can talk binary or base 64. Or other levels of representation that most of us can't understand quite well. But if we represent things in higher levels, like in simulations, with a lot of research, then it's much easier for humans to first create and view and perceive and feel the information, right? He talks about the theory of information. It's another article that I have to study, but regarding 2 dimensions and environment features, he spoke about that. Data first. So if we are creating environments that are adaptive, and we are not creating software written in stone, because the environment has some things written in stone, but the processes, the agents are not written in stone. They are adaptive. They are moving through the feedback loop and learning from them and becoming and changing, and becoming more resilient with time. So they can't be written in stone. The building blocks can, but not the high order components, right? So for that, we have to be data first, because the magic will occur at data level, not at code level. I know that this is just a matter of representation. In the end of it, everything's data. We are data. But as we are talking here about practical implementation of some kind of solution, we have to limit the two field. And the limit is that the engine of the thing, he doesn't mention engine in the book. I am mentioning by myself. But the building blocks are code, but not the setting, the setup of the environment, of the world, the agents that are living in this environment, in this world, and not the message that are being exchanged. So these things are data. And the last concept is that intelligence occurs in higher level order. I mentioned this sometimes during this podcast, but what's the idea of the author? His idea is that if we represent some kind of entity, some kind of thing, for example, an atom, virtually in a computer, we have a virtual atom, right? This is his first state. But if we create another entity, a higher level entity, for example, a molecule, using virtual atom, the molecule doesn't know that that it was made from virtual atom. So the molecule is a real molecule for the author. Sorry, I was talking molecule, but it's molecule. Sorry, I just asked it, Alexa. So in short, this is what he is saying, that higher order components that were made from other components that are virtual are not virtual but real, because they have the behavior, they don't know of what they are made of, so for them it's fine. It's a bold statement, but he compares, for example, if you have a super powerful machine that read your environment and put every atom, every piece of data that we have in real world inside this super power computer. So it was like a camera that scans the world and put it in your computer, and that if you scanned your room and your kitchen and everything is being copied inside that computer, but suddenly you start to film yourself, to record yourself, and now you have a replica of yourself inside the computer, right? But then you have two of you, because if you replicated every atom, the camera records using ray X, okay? So every atom of you, every behavior of you is replicated when you replicate like basic elements of you, lower level elements. Because if you copied atoms, you copied neurons, you copied your brain, so you copied not only the physical part of you, but the behavior of this physical element, the emergent behavior, right? So you have two of you. And for the person, for the you inside the computer, he's not a virtual you, because for him, he is you. So he will, the two futures, the future of the virtual you and your future will diverge from that moment and so on. But who of the two can tell he's not real, right? So that's the concepts of the book that I would like to feature, to highlight in this second read. And feedback loops, emergence, parallel processes, building blocks, adaptive software, 2D environment, data first, and intelligence live in second level order. I think these are all useful in our journey here in Hook Captain, and I see you later. Please subscribe to the channel and like this video if you liked it. See you later.